Hello all, welcome back to software maintenance class. This is our third class, and in this session, we are going to see what is software measurement and what are the different assessment criteria available for assessing or measuring the software. So there is a very famous line by Tom D. Marco: "You can't control what you can't measure." So measurement is very important because once you are able to measure, then you have control, and this control can be in many forms in terms of software. But let's see what exactly is the definition of measurement. So measurement is a technique in which the properties of an object are determined by comparing them to a standard quantity. So this is a clear definition of measurement. However, in terms of software maintenance or the software development life cycle, measurement helps to control a software project effectively. It is imperative to measure the activities and process that comprise a particular project. So we can say by measuring a process, we can easily evaluate and we can improve the outcomes, and we can produce quality work out of the product which actually we are developing. And therefore measurement is is a fundamental and is fundamental for software maintenance, and and also it can be applied in the various process of software maintenance in order to improve the development process on a continuous basis. So we can think measurement as as a software. We can think measurement as a process which or as a tool which we are going to use to to control the quality of the product or the project, or we can assess the productivity what actually we are doing. And moreover, measurement can be also used by software engineers to help and assess the quality of work products and to assist in tactical decision making as the project proceeds. So now let's see what are uh, what are the different use uses of or why actually we need this measurement. So measurement helps us to understand. So understanding can be in terms of process, it can be in terms of product, resource, environment in which we are developing the software, and also uh, by having these all information, we can establish some guidelines or baselines for comparison and for future assessments. So maybe we have developed a product, and based on based but now by measuring the process, the product, and the resource which we have used, and moreover the environment, now we can measure and we can establish a baseline. This is exactly what we need, the minimum requirement is, and based on which we can design a certain guideline, and we can reach to a certain. So it is going to help us to evaluate or to determine status with respect to plans. Uh, it is going to allow us to control the outcomes and change processes. So if there is any issues, or if the process or the resource which we have used or which we have followed in the software maintenance is not giving the right outcome, then of course with the help of this measurement we can always change the process. And measurement encourages us to improve. So by improving, here we means identifying the roadblocks, what were the root causes, inefficiencies, and other opportunities for improving product quality and process performance. So these are use of measurement in software maintenance. It helps us to understand, or maybe to correct. It helps us to characterize understanding of various of various of various entities in a particular in particular software maintenance. And of course, it also helps us to predict the outcomes. To predict the outcomes here, it means we want to gain understanding of relationship among the process and product, and we want to build model based on these relationship. So these are the three different uses of measurement. So the thing is, why actually why we need this measurement? So the thing that it turns out that if we don't measure, there are no real way of determining whether we are actually improving or not. And if we are not improving, then we can say we are lost and we are doing nothing. So measurement helps us to improve, and it helps us to compare the changes what we have done. And if you see these three different propositions, you may agree or you may disagree with these three. For example, a developer who drink coffee in the morning produce better code than those who drink orange juice. The more you test the system, the more reliable it will be in the field. If you add more people to a project, it will be completed faster. So these are the three different propositions with which you may agree or you may disagree. For example, if I take the second statement, we may agree with the second statement uh, if we have tested the system thoroughly, then the reliability of the particular software which has been developed in the field or where it is being used will be high compared to the system which is not tested thoroughly or rigorously. And but contradictorily, if we add more people to a project, it may turns out that it may lead to a faster completion, but adding more people to a project may increase complication, like for example managing or distributing the projects or the modules between the number of peoples which we have. So the thing is, uh, we may agree or we may disagree with these three with these three statements, but we want to measure. And measurement, basically we want to measure, and it measurement will be used to establish a process baseline from which improvement can be assessed. And this is the basic objective of measurement. So okay, so ISO IEC 25010 model. I think we have seen this model in our previous slides, and it talks about three different quality models: product quality model, data quality model, and quality in use model. So we have seen what exactly is product quality model and what are its different characteristics, what is quality in use model, and what are its different characteristics. And for data quality model, I ask you to see in literature what exactly is data quality model. But the thing is, if you see the black arrow, not the dotted line, the black arrow, if you see from the product quality model, in a particular human computer system, it is going to be used to measure the target computer system, which actually we have developed, and of course the target software, uh, which which we target computer system on which it is going to be executed, and of course the target software which we have developed. And if we talk about data quality model, it only will be helpful in measuring the data. It can be any kind of data which we have thought during the development of the particular product. And in but when we talk about quality in use model, it mainly focus on the entire human computer system. However, there are different factors which are going to influence the quality in use model, which are information system, target computer system, target software, target data, primary, secondary, or indirect user usage environment. So these are the are different 7 factors which are going to influence the quality in use model. For example, if the target software which is being used by the end user is not functioning is not functioning, or it is reporting so many bugs. So quality in use our quality in use model, the characteristics of quality in use model will tell us, or it is going to be, or it is going to focus on uh, on on those things which which by which the customer is not able to use the particular model. So the bottom line over here is, with this quality, these three different quality models, which the product, data, and quality in use, we want to measure different things in a particular human computer system. So the three P's of software measurement. So with regards of software and its process, we can measure three different things. First is product, second is process, and third is people. So we are going to see what exactly we are interested in measuring in product, process, and people. So when we say the product, we are more focused on the actual product which we have developed, means the actual software system which we have developed. And in this, and during the development process, there might be, it is possible, it is not possible, it is compulsory that there will be certain documentation involved during the development of a particular software. And of course, we are going to have other deliverables which associated with the development of a particular product. So measuring the product over here will be in terms of size of the product, the functionality which the particular product is going to offer, what is the cost associated with the particular product during the maintenance part, and of course various quality attributes. What are the different prime quality attributes of the product? So these are the these are the four different aspects which we are interested in measuring in terms of the product. And when we say we want to measure the process, we are here more interested in analyzing the way the product was developed, or the way we are using a way the technique or the process, the entire cycle which we are going to use in the development. We want to analyze those entire thing. And actually what we are interested in analyzing or measuring over here is what is the life cycle we have used in the development of the product, what were the deliverables produced by the product, by the process which during the process, and how are they analyzed, how actually these deliverables have been analyzed during the development, how can the process help to produce products faster, how can the process help to produce better product. So faster and better product will also come, we want to measure when we talk about the process. However, when we are measuring the people, we are more interested in analyzing the people who are involved in the development of a particular product. So when we say we want to measure the people, we want to measure how fast they do their work actually, how much bugs do they produce when they are writing a particular code, or they are performing some task in in particular life cycle stage. And of course, we are also interested in how many sick leaves do they take uh, during the development of a particular software, or maybe in a year. But the thing is, people do not like to be to being turned into numbers. This is the fact of industry, which people are very people do not like. Seriously, they do not like this thing. And however, measuring product, process, and people can be done. However, this measurement will be done, or will be done on the basis of data. So we need data to measure the people, process, and product. However, collecting data is very challenging task in software engineering, especially in measurement task. So what actually we want to make sure that the collected data should provide some useful information for the project process, and of course for quality management. And it should be done in a such a way that it the whole collection process should not be a burden on the development team. This is very important. So you can by the end of the day, you need to have some data that needs to be useful for the project, the process and the entire process, and of course for the quality. But the thing is, the collection process should not intervene the people who are there in the development team. And moreover, uh, un uh, we should try to be as unintrusive as possible. And of course, we should try to make the data collection process automatic, because collecting data manually will take a lot of time, and it will be a big burden on the entire team. And sometimes collecting data will be very expensive, and it can be very difficult to convince the management team that we are looking to collect data for these three things. So, what can be the possible way of collecting software engineering data? So, this 6 steps uh, is is a very used or very simple way or very ideal way to collect the data. The step starts first with you can establish the goal of data collection. What exactly is the way, or what is the goal of collecting the data? You can develop a list of questions of interest. Third, you can establish data categories to which category the data actually belongs. You can design and test data collection forms and program. You can have these forms and programs you can pre-design these forms and programs to design and test the collected data. And of course, you need to collect and validate the data, and finally, you need to analyze the data. So this is a possible collection methodology which can have the 6 steps. Now, if I talk about Motorola, for example, examples of metrics program. If you talk about this Motorola company, this giant company of has 7 goals, and in for which you can see on the slides. To, for example, improve project planning, increase defect containment, increase software reliability, and so on. So, in order to accomplish these 7 goals, there are different measurement criterias on which the Motorola company works. For example, what was the delivered defects? Once the product was delivered, what was the actually defect in the product? Was the process effective in the development? Means it is talking about it is talking about the whole development process. Was the process effective? And what was the reliability of the particular software which was delivered to the customer? Was the development or the maintenance part was has adhered to the schedule? And to what time, or to what was a certain time boundary in which the particular problem was opened, and of course when it was closed? And similarly, IBM has certain 5 set of metrics, which is also called 5 UP, and they are defined, and they are more focused on customer satisfaction. And if you see uh, post-release defect rates, customer problem calls, fix response time, number of defective fixes. So they are more interested in fixing the defects as well as customer satisfaction and for the customer problems. However, if you see Hewlett Packard, HP, they are heavily influenced by defect metrics. So they are not focused on the customer. However, they are more focused on the defects that is being found. For example, what was the average fixed defects per working day for a particular developer? What was the average engineering hours per fixed defect? Average reported defects per working day, and of course defects per testing times. What was the testing time for a particular defect? So if you see all these 3 different companies, so they all 3 have different measurement criterias, and they are and out of these 3, if you see, IBM is more focused towards customer and of course the defect. However, Hewlett Packard is more focused or more influenced towards the defects that the particular product has been introduced in a particular product during the development. So now we will see what are the different types of measurement. So measurement. So basically there are. So if you see this slide, measure, metric, and indicator. These are the three different indicators of measurement. Measure an appraisal or assess ascertainment by comparing to a standard. For example, Joe body temperature is 37.5 Celsius, so on. So this is basically a simple definition. I will not go in much detail with these three definitions. And I hope you know about what is this measure and what is the metrics and what is the indicator in measurement. Now, the next thing is reliability and validity of a measurement. So we need to understand what is reliability. So basically, reliability here refers to the consistency of the number of measurement taken using the same measurement method. So we are going to use a same measurement method, and the consistency which we are going to get after measuring a particular measuring a particular effect, or let's say if we are interested in something in a particular concept, and after measuring we are getting the same, more or less the same, on an average we are getting the same output. So it means this measurement, the product which we have developed is reliable, it is consistent. However, validity is completely different from reliability. Here validity refers to whether the measurement or metric really measures what we intend it to measure. So reliability is the consistency of the measurement. However, validity means we are more interested in the concept which we have developed, or the concept which we have developed, and we want to test whether that concept is being really being measured or not. So this definition is going to be cleared by the next slide. What exactly is reliability and validity? Okay, now if you see this figure, there are three different pictures. The first one says it is reliable, but it is not valid. Why it is reliable? If you see the data points, on an average, they are consistent, but actually we are not interested in measuring the outer circles. We are interested in measuring the inner black spot circle. So they are consistent. So, but actually, what we are intent to measure, we are not getting the black spot in the middle. So we can say the first picture over here is reliable, but it is not valid. Second, we can say it is valid because it is more or less uh, uh, it is more or less it is not, this time if you see, it is not reliable, but it is valid. Why we are saying it is valid? Because if you see the average, the errors from the black spot will be less compared to the first picture. So this we can say somehow or less it is valid, but it is not reliable. The consistency is not there because some data points are on the top, some are on the right, left, and also some are there at the bottom. So we can say this one is valid, but it is not reliable. But if you see the last picture, which all the data points are close to the black spot in the center, and we can say here that this picture is reliable and valid. So we need a software which should be reliable, means it should be consistent, and it should be valid. Valid means it should actually, what exactly we want to measure, it should give those output. So over here we are more interested in measuring the black spot in the center, and all data points are there. So it is consistent and it is valid in the third. So often very large projects or organization need a measurement planning, and so this is something which they need. And when they are doing this measurement things, there are certain questions being asked. So why are things measured? What actually is being measured? Who will measure? What parts of the system are you going to be measured? When you are going to measure? how will the data be collected and analyzed? So these are the different questions which comes into our mind when we are associated with a large project, or maybe a project which has more than 5 or 7 people involved in a particular project. So the thing is, we need to define how the measurement affect the business, the basis on organizing the work towards the management, and the ease of use to enable reliable results. And of course, we are more interested in understandability, because by the end, the software which the measurement criteria which we are going to be used, it should explain what actually we have measured, and and the results should indicate what component or event caused the result. So the thing is, we need to measure a certain component, and the result should indicate actually what has what has happened, and why actually we have got this result, whether it is good or whether it is bad. So we should be able to understand, and we should have some explanation about this fluctuation which we see after doing the repetition of the measurement in a particular software. So for requirement for any measurement will depend on these 4 things. First is objective, what actually we want to measure. It should be reliable in the sense, accuracy. It should be repeatable, and it should be economically supportive, and it should be reusable. Economically means it should not be in that the measurement should not be in a sense that it should consume, or it should ask or demand more resources or more cost. And it should be reusable. Whatever metrics we are going to use, measurement should be repeatable, and repeated measurement provide metrics which are comparable. So if it is repeatable, then it can be comparable, and if it is comparable, then we can have control over our software, and we can develop uh, a good high quality software. So the thing is, these are the 4 different requirements which we need during the measurement of a particular component or a module. So based on which there is ISO IEC 29119 testing process. So these are the different types of measurement for process we are seeing over here, and this measurement is being used for raw or general data. We can also use this measurement for work plan based indicator, project status based indicator, system completeness based indicators, test result based indicators, reliability, and of course QA efficiency based indicators. So these are the different measurement which we can use during a particular testing process. And when we talk about the product, this is the measurement will be based on ISO IEC 25010 software quality, and the quality. When we talk about the quality, it is going to measure the functionality, the performance, compatibility, reliability, security, all those 14 characteristics which we have seen in software quality model: portability, general quality in use, effectiveness, satisfaction, freedom from risk, and so on. So the basic measurement. So the basic meaning of measurement is simple enough to count from any type of system or project. So we want to we want to measure when we are there in a software development part. We want to measure what is the remaining budget versus what is the remaining time, because when you are involved in a particular development life cycle, you are more interested in knowing these things and these parameters. And if you are able to measure these parameters, the quality of the particular product will be high. For example, what are the amount of features you want to add versus remaining time, amount of features you want to add, what are the lines of code per feature. We over here we mean to say what are the amount of bugs, amount of fixed bugs that we have been fixed, how much hours have been used per feature, mean time between failures, mean time between unique failures, and so on. So these are the different basics things which we want to measure during the development of a particular module or a particular feature. Yeah, it is easy to use, but yield low amount of actually useful information from the viewpoint of maintainability. So in terms of maintainability, the things are going to change. For example, the complexity is going to increase. The identification of components prone to errors. The more the components which we have developed, it may be possible that they are more prone to errors. Amount of actual work needed. What was the actual amount of work needed to develop a particular product? How good are our our quality assurance practices? What exactly we follow in those things? So these are the few questions which we want to which we should take into account when we are developing a particular when we are performing a particular maintenance of a particular component or a particular product. So this measurement, now the thing is function point analysis. So in order to measure a particular software, we have this function point analysis, which was invented by Albrecht at IBM in 1979. So instead of measuring size, function point measures the functionality offered by a system. So let's see. So basically, function point metrics provide a standardized method for measuring the various functions of a software application. It helps us to measure the functionality from the user point of view, that is, on the basis of what the user requests and receives in return. And the objective of function point analysis is it measures software by quantifying the functionality that the software provides to the user, primarily based on the logical design. With this in mind, the objective of function point analysis is first is to measure functionality that the user requests and receives. It also measures software development and maintenance independently of technology used for implementation. So it is technology independent. It doesn't depends on any platform. So what are the different benefits of function point analysis? So organization can apply function point analysis and they can take benefit. For example, it is a tool to determine the size of a purchased application package by counting all the function included in the package. Uh, a tool It is a tool to help users determine the benefit of an application package to their organization by counting functions that specifically match their requirements. So once the requirement has been established during the SDLC first phase, the requirement gathering phase, this function point analysis can be used to match whether they are getting the same number of functionality by the delivered product. It is a tool which can be used to measure the units of a software product to support quality and productivity analysis. We can also improve the quality and productivity of the entire software product. It can be used to estimate the cost and resource required for software development and maintenance. So you can also use this function point analysis to estimate cost and resources required for software development and maintenance. And of course, it is a normalization factor for software comparison. So by the function point analysis, you can also compare one product with another product, and you can measure how much does it cost and how much functionality does a particular software gives you. So the simplest way to calculate a function point is as follows. So a function point is going to include there's 5 function points, or you can say different 5 measurement parameters, which is number of external input, number of external output, number of logical internal file, number of external interface file, number of external inquiries. And you see some numbers which are there multiplied by them. Let's see what these numbers are. And before that, let me tell you what this external input can be. For example, the number of external input can be the input screen and tables. Number of external output, it can be the output screen and it can be the report. Number of logical internal files, it can be the database or it can be the directories. Number of external interface, number of external interface file, it can be the shared database and shared routines. Number of external inquiries, uh, it can be the prompts or the interrupts which you are going to see on the which is there in the software. So these are the five different parameters and examples which I just mentioned, and the numbers which you see. So these are some predefined weight uh, with these parameters. For example, there are three different columns. So the first one is simple, average, and complex, and these weighting factors are associated with them. We can always take the average part, and of course, we can also take the complex. So it is going to depend on the problem which you have been asked to solve. So if it is an average problem, then if for those problem we are going to use the weighting factor weights, average weights factors, and we are going to multiply by it. So let's see this. So this is a particular question we have, and we in this particular question we have identified what is the external input, what is the external output, what is the logical internal files, and what is external files. And then we have written all the numbers based on which we have counted the numbers we have written in front of each parameters, and then we have multiplied each parameters with some weight matrix which we have seen in the table. Over here we have used the average weight matrix, and finally we got an output which is 28. So we can say the particular the this particular requirement specification has total functionality of this particular requirement has 28 functions associated with it. Similarly, we have function point extension. The original function point were sufficient, but various people extended them to make them more expressive for particular domains. The original, like for example, the original model correlated very closely with lines of code estimate. This was not the original intention for which the function point was developed. And some other model which was developed based on function point is general system characteristics, GSC extension, 3D function point for real time system, object point, feature point, scope management, and COCOMO. I'm not going to discuss each metrics over here, but let's see what is GSC extension, the first one. So the original function point do not address certain functionality which system can offer. For example, distributed functionality, performance optimization, and so on. So the general system characteristic GSC extension involves answering 14 questions about the system and modifying the original function point accordingly. So let's see how we are going to modify it. So these are the different 14 system characteristics, which starts from data communication, distributed functions, and so on to facilitation of chance. So these are the different 14 characteristics associated with GSC, and based on which the software engineer assigns a value between 0 to 5 to each question for these 14 questions, where 0 is not applicable and 5 means essential, and based on which we have a formula of the value adjustment factor VAF, which we can calculate as this is a this is a defined formula which we have, which we can use, which is 0.65 plus 0.01 summation of I is equal to 1 to 14. Why this is 14? Because we have this 14 function points extension parameters. So this 14 refers to those points, and CI over here is depends is indicating these 14 values for these 14 things. So you will be given certain values for these for these 14 parameters, and based on which you can modify the original function point as function point is equal to fc function point multiply by VAF, the function point which you calculated earlier, apply it with this VAF, and then you can get the new function point, the GAC part, which we say. For example, this is the consider the simple. Let us take the example. Consider the bug reporting system for which we already looked at, and suppose the analyst involved answers the GAC question as follow. The first example in which we have calculated a function point, and these are the 14 questions the GAC involves. And now these are the numbers which are being associated uh, uh, by the engineer, by the system engineer, or you are by the system engineer based on between 0 to 5. Now the total GAC score over here is 25. You need to add it. In the previous formula, if you see, it is summation of I is equal to 1 to 14 of CI. So here CI represents this entire GAC score. So now you have 0.65 plus 0.01 into 25 is equal to 0.9, and the function point will be here is 28 cross 0.9, which is 25.2. But the thing is, we need to note over here is the GC extension can increase or decrease the original count, and this GC extension is going to have much more significant influence on function point count when we have very large systems. Similarly, we have another metric, which is cyclomatic complexity, and it is a software metric that is used to measure the logical complexity of the program code, and it helps us to predict the testing effort, it predict defect, predict maintenance cost, predict and identify problematic components, and it also helps us to decide on revisions or component rewrites. So this cyclomatic complexity metric was designed by McCabe in 1976, and it is being used as an indicator in a program testing and to understand the particular attribute which we have developed. And the core of the cyclomatic complexity design is based on graph theory, which helps us to measure the number of linearly independent path comprising the program. Program with lower cyclomatic complexity are easier to understand and less risky to modify. So this is very important. You need to remember about cyclomatic complexity. So if your cyclomatic complexity is between 1 to 10, you can say it is well structured and well written. The code is well written. It is going to give you high testability. It will have less cost and effort. However, if this is a formula by which you are going to calculate cyclomatic complexity, and once you get the value of m, if it is between 1 to 10, then you can see it is the code which you have designed is well structured and written good. It has high testability. It ensures high testability. It requires less cost and effort. And similarly, if it is between 10 to 20, it is complex code, medium testability, medium cost and effort. 20 to 40, very complex, low testability, high cost. And if it is above 40, if you are this McCabe cyclomatic complexity comes out to be above 40, it means it is very highly complex code is being used to develop the particular software, and it is not at all testable, and it is a very high cost and efforts is being associated with the particular software. So let us see what this formula is. It says E minus N plus 2P, where V in the bracket G refers to the cyclomatic number of graph G. E is the number of edges, N is the number of nodes, and P refers to number of unconnected parts of the graph. So this is a simple example. If you see in this example, you can count the edge. It turns out to be that edge is 7. And if you count the nodes, it turns out that the number of nodes is 6. And P, the unconnected, is 1 over here. And if you put if you put this numbers into this formula, it turns out that the cyclomatic complexity for this particular program is 3, which means that it is well structured and it is very easy. It is very easy to follow, and it can be a very less cost is associated with this particular uh, flow chart. However, it is very easy. I understand it is very simple and very easy, but in real time, you are not going to find such an easy graph or flow chart to calculate cyclomatic complexity. Of course, basically the cyclomatic complexity is equal to the number of different paths which the program can take, and cyclomatic complexity is additive. You can have multiple cyclomatic complexity, and you can add them mg1 plus mg2, and you can have the final thing. And like I said, to have a good testability and maintainability, MACAB recommends that no module have a value greater than 10. So you should have a value cyclomatic complexity value between 10. It should not exceed the value 10. This metric is widely used and accepted in industry also. The next is Halstead software science. This Halstead software science was developed by Halstead in 1979, and it totally depends on the number of tokens. So let's see what exactly it is. So the tokens are the basic syntax units which are distinguishable by a compiler. And in a computer program, you are going to see a collection of tokens that can be classified into two things. One will be operator and operand. Operator means any symbol or keyword in a program that specifies an algorithm is considered an operator. And operand in an algorithm or a program, a symbol is used to represent data or constant or variable, label, etc. is considered as an operand. So these are the primitives: n1 small n1 n2 capital N1 n2, where small n1 represents number of distinct operators appearing in a program, and n2 refers to number of distinct operands appearing in a program, and n1 capital N1 is the total number of operator occurrences, n2 is total number of operand occurrences. And based on these primitives, Halstead has defined a series of equations which are these. Which the first one is can be used to calculate vocabulary. Second, the length of the program, the volume, level, difficulty, effort, faults, and so on. So I'm not going to discuss these formulas with you in detail. This will be your assignment. You have to go into you have to find these formulas, and you need to understand what actually is this formula used to calculate, and based on which you are going to get some assignments to calculate this Halstead software matrix for a particular program. So what to remember from this lecture? So you should now understand the definition of software matrix and measurement, and the objectives of measuring things. Why actually you want to measure? You want to control a particular software, and in order to control, you want to measure. The different types of measurement which you have seen, and the common metrics for software development. The common metrics includes Halstead, cyclomatic, and MACAB. 3 we have discussed, and other I have given you as a task to see the COCOMO and other models. So these are the different measurement criterias are used in software maintenance. Okay, so see you. I'm going to see you in next class. We are going to see next class. Bye.